Welcome my dear learners for this course on engineering graphics. From today we are beginning a new module in this engineering graphics course, that is orthographic projection of plane surfaces. Before heading to solve problems on orthographic projection of plane surfaces, first let us discuss what is the meaning of plane surfaces. There is nothing like plane surface in nature. Plane surfaces are nothing but solids with negligible thickness. For example, let us consider a washer used in bolts and nuts. The washer, if you consider, its thickness is negligible when compared to its diameter. What I mean to say is that if you measure the dimension in x-axis and y-axis, which will be greater when compared to the dimension in z-axis, that is, thickness is negligible compared to its diameter. Similarly, the plate what we use to have our food, its diameter is higher, larger when compared to its thickness. So thickness can be neglected when compared to its dimension in x and y axis. So solids whose thickness can be neglected are considered as plane surfaces. Under plane surfaces we will be discussing on triangular laminae, rectangular laminae, square laminae, pentagon, hexagon and circular laminae in this course. Another important note that has to be noted here is that first thing is, for any laminae, if two lines come and meet, this is called as corner. This is called as corner positioning. Whenever two lines come and meet at a common point, that point is termed as corner position. And for these lines we call it as edge. These lines are called as edge. Corner position and edge position are very important point to be noted to solve problems on orthographic projection of plane surfaces. Another important note is that to solve problems on plane surfaces we will be using three position method. That is, in first position we will not incline the laminae to any of the planes. In case of orthographic projection of plane surfaces, we will be discussing on problems in which laminae is inclined to both HP and VP. In three position method, in the first position we will not incline the laminae to any of the projection planes. So it will be resting on HP, means it will be resting on HP. We will not show the inclination with any of the planes in the first position. In the second position we will show the inclination with respect to the plane on which it is resting. In the first position the lamina is resting on HP, means in the second position I will show the inclination with respect to HP itself. If in the first position the lamina is resting on vertical plane, then in the second position I will show inclination with respect to vertical plane, and in the third position I will show the remaining inclination. That is, in the first position we will not incline the laminae to any of the projection planes, neither to vertical plane nor to horizontal plane. In the second position I will show the inclination with respect to the plane on which it is resting in the first position, and in the third position I will show the remaining condition what he has given in the question. So with this very brief note on orthographic projection of plane surfaces, let us address problem number 1 and 2 in today's lecture. The problem number 1 states that an equilateral triangular laminae of 25 mm side lies with one of its edges on horizontal plane such that the surface of the laminae is inclined to HP at 60 degree. The edge on which it rests is inclined to VP at 60 degree. Draw the projections. So we have a equilateral triangular laminae of 25 mm sides lies with one of its edges on HP. So it is resting on HP. In the first position I don't show inclination to any of the planes. So therefore in the first position the equilateral triangular laminae will be lying on HP. I should take such a way that he is giving that the surface of the laminae is inclined to HP at 60 degree. The edge on which it rests is inclined to VP at 60 degree. Draw the projection. Here I want to show the inclination of the edge. The edge on which it rests. It rests on one of its edges. In order to avoid confusion, we will always take left hand reference. That is, if the laminae rests on HP with one of its corner, then I will draw the laminae such a way that I will get corner towards my left hand side. For hexagon I will draw such a way that I will get corners on two sides. For pentagon I will draw such a way that I will get corner towards left. For triangular laminae also I will draw such a way that I will get corner towards left. If the lamina rests on its corner, on its corner. If the lamina rests on one of its edges, I will draw the first position such a way that I will get the edge towards left hand side. That is what I mean left hand reference. So we will maintain the left hand reference throughout this module. Now the lamina is resting on HP with one of its edges. The edge on which the lamina rests is inclined to VP at 60 degrees, he says. So the lamina is resting on HP with one of its edges. In the first position, I will draw the lamina as it is without showing the inclination with respect to any of the planes, such a way that I will get edge towards my left hand side. This is because he is stating that it is resting with one of its edges. So first let me construct the first position of the given problem. Let us address problem number 1 first. To address problem number 1, let us draw VP and HP to show the front and top view of the given problem. That is, let me draw XY line first, drawn. Let us take this as X, this as vertical plane, this as horizontal plane. Now in position 1, I will rest the lamina on HP without inclining to any of the planes, such a way that I will get edge towards my left hand side, because as I said we will be using left hand reference for the entire module. So I want to construct an equilateral triangle of 25 mm sides. So I will draw an edge towards my left hand side. Edge means line, corner means the intersection of two lines. So I will draw a vertical line. So since the lamina is resting on HP, in the top view I can see the triangle, but in the front view I can see only the straight line, correct? So therefore in the top view I can see the triangle, equilateral triangle of side 25 mm. So let me draw that. So I mark 25. Now using compass I will construct this equilateral triangle of 25 mm sides. Now use compass and cut arcs. So this is 25. Now construct equilateral triangle. So draw an arc, from the other end you intersect this arc. So this gives us the equilateral triangle. This gives us the equilateral triangle of side 25 mm, right? So I will mark it as A, B and C. A, B and C. Now I will take the projection. So I take the projection with very thin lines. I will take the projection, and this I will mark it as the front view of the lamina will be an straight line. So observer will be here at the bottom. So to the observer A is visible, C is invisible. So here it is A dash, C dash, and here it is B dash. So this is the position of the observer in the front view. In the front view this is the position of the observer. In the top view this is the position of the observer. So this completes the first position. The lamina is resting on HP without inclining to any of the planes. Done. In the second position I should show the inclination with respect to HP itself, because in the first position the lamina is resting on HP. So how much is the inclination with respect to HP? With one of its edges on HP such that the surface of the lamina is inclined to HP at 60 degrees, he says. So now incline the lamina to 60 degree such a way that it will rest with one of its edges. So this is the edge, that edge is A dash, C dash. So taking A dash, C dash as the reference, you mark 60 degrees. That is, measure 60 degrees. I measured 60 degree. Now you transfer this lamina. So in the front view the lamina is measuring 21 millimeters. So draw a line of 21 millimeters. At an angle of 60, you draw a line of 21 millimeters. Drawn. Clear? So I have taken this, I moved here and rotated at an angle of 60 degrees. This is A dash, C dash is invisible, and this is B dash. Now take the projection and complete the sketch. That is, take the projection from here as well as from here. Also you take the projection from C and from A. Also project B. So intersection of C and C dash is C. Intersection of A and A dash is A, and B and B dash is B. So now construct the triangle. Done. So first position, second position is showing inclination with respect to HP. Anything shown with respect to HP will be plotted on VP. Anything with respect to VP will be plotted on HP. So inclination with respect to HP will be shown on VP. Now in the final position I should show the remaining condition what he has given. The remaining condition is that the edge on which it rests is inclined to VP at 60 degree. On which edge it is resting? It is resting on edge A dash C dash. On which edge or on which corner the lamina is resting can be seen in the front view of the second position. Kindly make a note. The front view of the second position is this one. If I inspect the front view of the second position, I can see that the lamina is resting on this point on HP, such a way that that is edge, because we have A dash C dash. So A dash C dash is a line inward to the board. So when I look at that, I can see the point nearer to the observer, that is A dash, C dash is away from the observer, therefore I shown it in brackets. So it is resting on A dash C dash on HP. So this has to be inclined at an angle of 60 degrees to VP. That has to be shown on HP. So that is AC. So incline AC to 60 degree with respect to VP. Anything with respect to VP will be shown on HP. So therefore first draw a line at an angle of 60 degrees. Draw a line at an angle of 60 degrees. Let me draw a line at an angle of 60 degrees. So I have drawn a line at an angle of 60 degrees. Now if you observe, this entire dimension is 25 itself. It is unaltered. So therefore draw AC on this line. Draw AC on this line which is 25 mm. Drawn AC. So this is C and this is A. Now exactly at center you measure how much is this dimension. That is, I call it this as M. So M is a midpoint of AC. You know that. How much it measures? That is M to C. M stands for midpoint. How much it measures? You cross check. So it is measuring 12 for me, 12 mm. So exactly at center you mark exact center, that is M. From M you show 12 millimeters, small line which is very thin, because that is for our construction. Now I have placed it here. Locate point B, that is corner B. So I got corner B. So I picked it, placed it such a way that AC is inclined at an angle of 60 degree to VP. Hope you followed. So to transfer, first AC measures 25, I have done. Find the midpoint will be at 12.5, and I measured this one, this is measuring 12 mm. So I have drawn 12 mm perpendicular line to AC. Now you take the projection. So if I take the projection, this is C, projection of C, and this is B, and B is here. So I have taken projection of A and C. So this is B. So B and B dash, in front of you it is B dash, A and A dash, in front of you will be A dash, C and C dash, in front of you will be C dash. So connect this. This is the final position. So this is the final position. So this is the final position of given problem. So A dash, B dash, C dash satisfies what he has given for us. That is, the lamina is inclined an angle of 60 degree to HP, and the edge on which it is resting is inclined an angle of 60 degree to VP. So this completes the given question. This is Y. This is the solution for problem number 1. This is how we should solve. Next, move for problem number 2. A triangular lamina of 25 mm sides is resting on HP with one of its corners such that the surface of the lamina makes an angle of 60 degree with HP. If the side opposite to the corner on which the lamina rests makes an angle of 30 degree to VP, draw the top and front views of in this position. First, we have an triangular lamina of 25 mm sides. So all the sides are measuring 25 mm. Which triangle have all the sides equal? That is equilateral triangle. So I should draw again equilateral triangle is resting on HP with one of its corners. Kindly make a note. In problem 1, it is resting with one of its edge. In problem 2, it is resting with one of its corners. So therefore, I should draw equilateral triangle of 25 mm sides such that I will get corners towards my left hand side. Next, moving for solution of problem number 2, let me draw XY line and mark VP and HP. So I have drawn XY line. I call it as vertical plane and horizontal plane. Now I want an equilateral triangle such that I will get corner towards my left side. So therefore, I will draw vertical line towards right. Drawn, which is 25 mm. In the first position, I should not incline the lamina to any of the planes. Just place the triangular lamina on HP. In the top view, I can see the lamina with exact dimension, that is 25 mm, such that I should get corner towards my left hand side because it is resting with one of its corner on HP. Yes, given in the question. Now using compass, we construct it. Using compass, we complete the drawing. Done. Complete the triangle. So this is the required triangle. I got corner towards my left side. So this is A, B and C. Right? And each side is measuring 25 mm. Show it properly. Each side is measuring 25. Now take the projection. So if I take the projection, the lamina is resting on HP. In front of you I can see only a line. Now dark this. This is the front view of the lamina. So draw a very thick line. So observer is here. For him A and B is visible, C is invisible. So it is A dash, B dash and C dash. One more hint is that for corner you will get only one alphabet. For edges you will get two alphabets. Kindly make a note. If you get two alphabets, it is edge. If you get one alphabet, it is corner position. Now since it is resting on HP, in the second position I should show inclination with respect to HP itself. How much is the inclination with respect to HP? The surface of the lamina makes an angle of 60 degree with HP. So now this should make 60 degree inclination with respect to HP. So for that, I will take the position of A dash. A dash I taken, and I will show inclination of 60 degrees. What is the line dimension? It is again 22, same 22 mm, same what I got there. First I want 60 degrees, mark 60 degrees, mark 60 degrees, mark 60 degrees, measure and transfer the lamina. So lamina is measuring 22 millimeters, so transfer it. Lamina is measuring 22 millimeters, transfer the lamina. Transferred. This is B dash, C dash, and the lamina is making an angle of 60 degrees. Now take the projection. Take the projection. C and C dash, I should take projection till here. B and B dash, I should take the projection till here. A and A dash, I should take projection only till here. So I got A, B and C. Now join this with very thick line to get the lamina in the second position. To get the lamina in the second position. I got the second position. What is the final or third position? The side opposite to the corner on which the lamina rests makes an angle of 30 degree with VP. Which is the side opposite to the corner on which it rests? As I said, the second position front view will give us the details of lamina on which it is resting. The second position front view is this one. Here if I observe, it is resting on corner A dash, right? So edge opposite to the resting corner. So opposite to A it is BC. Edge opposite to the resting corner A dash is B dash C dash. So therefore BC should be inclined at an angle of 30 degrees to VP. So you make 30 degrees, draw a 30 degree line, draw a 30 degree line. Here you can observe we have picked it and placed it like this. You can also draw 60 degree and place it on that. So you can give totally 4 different solutions for this problem in the third position. I can take B downward and I can draw 60 degree line and place it on that, and also take B nearer to the observer. So totally 4 possible solutions are there for every problem what we discuss on plane surfaces. So any of this is correct, no need to worry. What we follow, we'll follow a proper convention throughout to avoid confusion. That is, we always take the lamina and place it like that. So I am taking this lamina and place it like this. So therefore I will take 30 degrees from here, 30 degrees from here, measure 30 degrees, draw a 30 degree line, drawn. So this angle is measuring 30 degrees. Now pick it and place it like that. Here also that is what I done. I picked it and placed it. So pick it and place it like that. This is how we will solve throughout for this module. We will always rotate second position front view counterclockwise, whereas third position top view clockwise. We will maintain the common method to solve problems so that we can avoid confusion. However you solve, any of the 4 solutions what you give is correct for each problem. What I mean to say is that 60 degrees we have done. B I can write here. From M I will measure how much is this length, I will measure and draw B, construct B here and take the projection. I will get a different view in the front view. That is also correct answer. Instead of taking 60 degrees like this, I will take 60 degrees like this. Pick it and place it. That is also correct. Invert it and place such a way that B will come nearer to the observer. That is also correct. Totally 4 solutions I can give for these problems. Don't worry about that. Give any one of the solution. Don't worry about the result. All 4 solutions are correct. Unless otherwise, he clearly states in the question what should be nearer to the observer. In this case, the edge is nearer to the observer. Correct? AC is nearer to the observer. Now we will make corner nearer to the observer. That is, B and C is maintaining its original dimension 25 mm. So I will mark 25 mm. I will mark 25 mm. So mark 25. So this is B and this is C. Right? Now you measure this length. Call this as M. So M is the bisector of BC, which is at 12.5. So if I measure A to M is measuring 12 millimeters. 12 millimeters. So draw 12 millimeters perpendicular to this line. Draw 12 mm perpendicular to this line. Drawn and call it as M. Draw very thin line, because this is for our construction we are using. The lamina is ABC. Clear? Sorry, this is A. Directly I will get A. This is M. Correct? And this is measuring 12.5. Sorry, 12 mm. 12 mm. So from there you connect. So if I connect, I will get ABC. So such that this is inclined. Observer will be here. To the observer, corner is nearer. This is the solution where in which corner is nearer to the observer. As I said in the front view, observer will be here. So to the observer, this edge AC is nearer in this position. Whereas here I drawn such a way that corner is nearer to the observer. He has not given any specific condition which is nearer to the observer. Don't worry about the final position. You can give any of the solution out of 4 which I have said. Now complete the final position of this. C is at the top. So project C and B. So connecting which I will get the solution as B dash, A dash and C dash. This is B dash, C dash, A dash. So this is the final solution what he has asked in the question. This is what representing the given problem. This is how we should solve problems on orthographic projection of planes using 3 position method. Kindly make a note that intersection of 2 lines is called corner, lines are called edge. Always we will keep using left hand reference. That is, if it rests on corner, I will draw such a way that I will get corner towards my left in the first position. If it rests on edge, I will draw such a way that I will get edge towards my left in the first position. In the first position, we will not incline the lamina to any of the projection planes. We will place as it is. So top view will give us the true dimension with the true picture of the base of the laminae if it rests on HP. If it rests on VP, then front view will give us the details of the lamina, whether it is pentagon, rectangle, triangle, hexagon or circular lamina. Here both problem number 1 and 2, the equilateral triangle is resting on HP. So I kept the equilateral triangle on HP. In the top view, when I visualized, I got the true dimension of equilateral triangle. In the second position, show the inclination with respect to the plane on which it is resting. So it is resting on HP. So therefore I should show inclination with respect to HP itself, which is shown on VP. This we have already learnt from orthographic projection of points and orthographic projection of straight lines. Anything with respect to HP will be shown on VP. Anything with respect to VP will be shown on HP. Next we show the remaining condition what he has specified. So this is how we will solve problems on orthographic projection of plane surfaces. With this I conclude this lecture. That's all from this lecture. Thank you all.